Hello everyone. In this video we are going to evaluate different conversion types: implicit conversion, explicit conversion. And so this will help to understand how these different variable types can be actually handled in C#. Let's begin. And let's create a new project. Create a new project. Okay, so what we're going to choose is this one, a project for creating command line applications. Can run on .NET, on Windows, Linux and Mac. So this is what we want. So we click on select, next. At this point I will call it here conversion types. And I want actually to save this one into my folder. Great. Conversion types. I think we're ready to go. And we wanted the .NET. We can do .NET 9. Create. Okay, so let's begin. Implicit conversion. Okay, let's start with implicit conversion. So we start by saying, let's say my integer, int, my integer, and I will say equals 26. Okay. Now I create a new variable, double, and I will call it my double as suggested by the system. And I can actually encapsulate my integer in it. And this option doesn't create any problem. Why is that? Because my double is a variable type which, as if we hover over it, it's a floating point number, double precision, and integer is 32-bit. So we have actually the container of my double can actually contain anything that is in my integer, isn't it? So that's why it's working without any problem. So we have, in this case, an implicit conversion from integer to my double. There is no loss of information when I'm using implicit conversion. The target type is guaranteed to hold all the information. We can also convert an integer into a long. So let's create a long variable, and I will call it my long, and this is equal my integer. And in this case works as well because integer long is just an expansion of integer as a variable type. We are overshooting here, but long, as you can see, is a 64-bit signed integer. Double is a double precision floating point, and integer is a 32-bit signed value. Okay, so that's why we can also do an implicit conversion from integer to long without any loss of information. So this is an implicit conversion from integer to long. And once again, no loss of information. So we don't have data loss because my long can contain more data than my integer. This also works with a float number. Okay, so I can create a new variable. Let's say my double 2. It's equal to my float. Of course, I need to create my float variable first, right? Otherwise, the machine doesn't know that. So I can create float, my float, and in this case, I will create a long number. Let's say with an F at the end to indicate it's a float number. At this point, I will say that my double 2 is equal my float. So let's call it my double. My double is equal my float. So this is also implicit conversion from float to double. Perfect. This is because my double has more range, so there is no problem in encapsulating the values of the float variable. Okay, so this is implicit conversion. Of course, we cannot do the other way around from, for example, my double or my long or my float into an integer, because integer cannot store, cannot hold that big numbers. Okay. So we have seen so far what is implicit conversion. Now, what is explicit conversion? Explicit conversion is when we cast one variable into another variable type. Let's see with a practical example. Okay, now we're gonna see explicit conversion. In this case, let's say I want an integer variable and I will call it my integer 2. We want to convert into a long, and that is not possible, no? And we know why. Because long is a variable type that is too big, is a bigger than integer. But what we can do is we can cast the integer variable by adding with brackets int for integer into my long. See, the error has disappeared. So the error is now gone, and we can store a big number, my long, into an integer variable. However, we need to be very careful of what we are casting in our my long variable, because it can be distorted. Let me make a clear example. Let's create a long variable, and we call it my long 2, and this my long 2, let's say, is equal to, let's say, a big number. Okay, there we go. Perfect. Now if we want to cast my long 2 into an integer, this will not work properly, because integer cannot hold more than a 32-bit number, and this number is longer than a 32-bit. So let me show you concretely what is gonna happen here. So if I write console line, I will call it my integer 2. Let's see what is the outcome variable. Let's run this application and see what is the outcome variable. Okay, as you can see on screen, the machine has printed on screen a value, but the value is totally different from what was my long. And the reason is that by doing this casting, we couldn't accommodate a big number, this one, into the integer. So it is our responsibility to make sure that we can actually cast the number into the integer. So let's make it now shorter. This will be absolutely within the range of the 32-bit of integer, and we rerun the application. This time the conversion from my long variable into integer, it was successful, and the reason is because the variable, the value that was assigned to the variable my long, is a value that can be also easily get into an integer. So this second value that we have casted in to an integer variable is within the range of values that an integer can manage. Now I want to do casting from a double into a float variable. So in this case, I will create a variable. I will call it here my double 2, that is equal to, let's say, big number. Name and double 2 does not exist in the current. Oh yes, of course, I will to write here double. Okay, so this is our double number, right? And now what I want to do is create my float, I will call it 2. It's not been used before, so let's do that. Equal to my double 2. Now there is an error, of course, because a float is less than double, right? So we can casting the double variable. We can say I want my variable double, that is casted into a float, and let's see how this will go. Okay, my float 2 is equal to my double. So let's write this one. Console write my float 2, and let's see what is the outcome. Let's run. There we go. So now what do we have on screen? We can see that when we printed the new floating variable, which has casted my double, the casting happened up to the number 1, 2, 3, 4, 1, 2, 3, 4, and then these 5, 6, 7, 8, 9 have been truncated. That is showing to you that in this case we haven't had a distortion of the number like it happened in the previous example when we wanted to put a long into an integer, and only when the long was short we could actually accommodate that. But in this case, a float can actually do the job by casting a double into a float, but there will be a limitation, so not many digits after the dot can be accommodated into this. Great. In this case, by doing explicit conversion, we have lost a bit of information.